So to list the files, you type a lsblk. Okay, and this is would be the output here, and it gives you the size also, 16, 8, 24, 32. Okay, so let's move on. So everybody is familiar with the hard drive, right? I mean, I don't have to tell you the hard drive. So this is what you got here in your computer. This is what it's sitting here. It's SATA and SSD. This is what a SSD hard drive would look like. There is no moving parts in the SSD, and there are moving parts in here. Okay, so we don't really need to worry about this as Linux engineers. The hardware part is usually be handled by the different group. Okay, so now what we're gonna do is to make this hard drive usable, you just simply can't use it, right? There is no way you could use it here. Let me try something here. Why don't we try cd/dev/sdb. Okay, so this is the drive here. Okay, and if you try to go inside the drive, and it says it's not a directory here. So what we're gonna do is we're gonna run some commands and then make it usable so that we could use the disk here. So for that, we have two concepts. Either you could use the fdisk concept, or you could use the logical volume concept here. So we'll use both. And these next sessions are very, very important here. By the time we are done with managing the disk drives, you shouldn't miss a class here. It's very important that you keep up with this, and once you master this, it's gonna be really good for your own benefit. Okay, and it wouldn't be long before you know how to use this. So you could use two ways to manage the disks. One is called fdisk. Manage the devices, or manage a hard disk. Okay, so one is fdisk, and the second is LVM. Okay, so let's see what is fdisk means. So what you would do is let me type fdisk. Okay, so this is a built-in utility. It's coming down from the real mother, which is Unix. It's coming down from there. Command line utility disk partition for what is known for format in dialog driven command in Linux, used for creating and manipulating disk partition. It is used for view, create, delete, change, resize. Okay, so Oh, it's coming from IBM. And so fdisk, we'll just keep this as a fdisk is a fixed disk program. Okay, let's keep it like that for our understanding. So what is fdisk? Fdisk is a fixed disk program. Okay, and LVM, and LVM is logical volume manager. LVM stands for logical volume manager. Okay, and LVM is used in Linux. When it comes to Linux, LVM is used all the time. So I'm going to show you both ways, but you have to concentrate more on LVM here. Okay, so let's work on fdisk. So okay, so what we're gonna do is we're gonna pick a drive here, right? We're gonna pick a drive. Let me clear this. I'm gonna do lsblk. Okay, so let's work on this drive here, SDB. Okay, so what we're gonna do is first use the fdisk commands here. Okay, so what we're gonna do is we're gonna use the command fdisk /dev/sdb because this is where the folder is. This folder, the full path for SDB is dev/sdb. What would be the path for SDD? Okay, all the hard drives going forward is going to be in dev. Here, I think I explained you yesterday that it all sits in the /dev environment, /dev directory. Doesn't matter what kind of disk it is. If it's any other disk, it still be in a dev. Dev stands for device directory. So let's run this command here. We run the command fdisk sdb and then we'll hit enter. Okay, and now we went into the fdisk utility and it has the commands here. It says M for help here, so it will give us the list. Okay, so let me start copying this. And then this command, I'm gonna readjust this so that it looks easier on the eyes. So I'm gonna hit enter, and this is the menu we have here. Okay, so it has a lot of menus here, but what we are interested in is in number P. We want to see what is available on this disk here if there are any partitions on the disk. Okay, so I'm going to do P and hit enter. So it got some information here. Okay, and then it is saying there is no partition here. So I'm going to do P and enter. So now I'm going to do M again for the menu. And then what I'm going to do is create a new empty DOS partition. And then what we're going to do is N for new partition. I'm going to hit N and hit enter. Okay, so N and hit enter. So now it's asking me, there are two kinds of partition in there: primary partition and extended partition. On the disk, the maximum partitions you could make is 4. Doesn't matter if you have the primary partition or not, the maximum partitions you can make on your disk is 4 partitions. Okay, so let's go ahead and this is P, right? So I'm going to make P as a primary partition and hit enter. Okay, and then it's asking us what is the partition number. I'm going to give the partition number 1 because it's already set as 1 here. So I'm going to hit 1 and hit enter. Okay, and it's telling us what is the size you want to use for this disk. Okay, so the size I want to is a 16 GB, so I want to use about how much I want to use? I want to use about 8 GB. Okay, so out of 16 GB we're going to use only 8 GB. So I'm going to do plus 8 and uppercase G. Okay, and I'll hit enter. Copy this. Uh-oh, I think I messed up. This first sector. Quit without saving. Okay, I'm gonna start over again. I'm gonna go F disk and then I'm gonna go into menu. What I need now is new partition, N enter, and then select if it's a primary or secondary. So I'm gonna do number 1 and hit enter because I want primary partition. So I'm gonna hit P and enter. And then the partition number, I'm going to hit 1 and enter. And default sector is asking you, so all you have to do is just hit enter there. So accept the default. Okay. And now it's asking us the size here. So now you give the size plus 8 GB. 8G. You don't need to put B in there. And I'll hit enter. So the partition has been created. Okay. And then I'm going to say M, or I'm going to say P is for print the partition table. Okay. So I'm going to do P and hit enter, and you could definitely see that the partition information is here. the partition has been created. Okay, now what we need to do is, I'm going to the menu again. To save what we have created here, you have to go W. Use W to write to the disk and exit, okay? So I'm going to type W and hit enter. So what will happen is it will write and quit. Okay, so...
Hey, Mr. Zafar, quick question.
Yeah.
When you did the plus 8G, the same thing happened that happened before on my screen. Did I do something wrong?
What is the output?
It gave me. It's saying last sector plus sector is the same thing that came up before.
Yeah, fine. I got the same thing too, right? But look at here.
But it did.
The partition 1 type Linux and of size 8 GB is set.
That's not. It doesn't say that on my screen though. That's what I mean.
Okay, let me look at it. Give me team viewer.
Okay. 1 second. The ID is 200
200
255
123, right?
123, yes. And password is JVM 698.
698.
JV, V as in Victor. M 698.
Okay, I'm in your system. No, yeah. So I did a mistake here. So just type Q and enter.
Okay.
Okay, hit enter. Okay, it won't quit, right? Okay, hold on. Do Control C. Okay, clear the screen. Okay, now go to fdisk again. Yeah, and do P to print the partition information.
Okay.
So nothing is created. Good. Now do M and enter. So what you need is you want to create a partition, new partition. So N, enter.
N, right?
Yeah.
Okay.
And P, we want to create a primary partition. Enter. And then partition number 1, enter. Over here, just simply hit enter.
Okay.
Now type plus 8G. Uppercase G, yep, enter. And then do P, enter. Okay, so the partition has been created.
Okay.
So save and exit, so W, enter. Okay, yeah, you are caught up with me now. So,
okay, thank you.
Sure. So what I'm gonna do is I'm gonna clear the screen, and the partition table has been altered. So this is the output you get. Can you go on mute, please?
Sorry about that.
Yeah, no worries. Okay, so now what we're gonna do is we're gonna do LSBLK, okay? So in here you see SDB, and there is a partition we have created here. Is going to take the number SDB. Where is the one coming from? One is coming from here. We gave the default partition number 1. We could have given 2 too. If you have given 2, you cannot use 1 anymore. Okay, so the disk size is 16 GB, and then out of that 8 GB is being used. 8 GB is free. And the part means partition here. Okay, so now let me copy this information. So I'm now going to keep everything in here. I'm going to get rid of this and get rid of this information. So I'm going to highlight this. And then it's being used only 8 GB. And part means partition. Okay, so we are not done yet. So now what we do is run the part probe. Below list. Okay, now there is one more command called blkid. You hit enter. Okay, what is the blkid do is it will register and it will show you all the disks which are being seen by the system here. So the disk is not being seen by the system yet. For that you have to type this command here, part probe, PART PROBE. So what this command does is it will go through and check for any new partitions or any new devices which are connected, and hit enter. It takes few seconds and it'll come back again, and you type lsblk. Now you should see the okay, the disk is not being shown here. Okay, yeah, we're not worried about that. You still run this command here, part probe. Okay, it will be beneficial here. Why? I'll show you in a minute. Because we won't be okay, we need to make the type of the file system. Okay, so the type of the file system Linux system is using is either ext4 or XFS. I'll explain you a little later. Okay, what is the file system here? So now what we're going to do is create file system. You guys heard like Windows has an NTFS file system, and they used to have FAT32 or FAT16 file system. So file system is a file allocation table. Okay, so now the command for file system is mkfs. MKFS stands for make file system, and then ext4 is the name of the file system we're going to use, and then we're going to say dev/sdb1. okay, I'm going to hit enter. So what happened here is it ran through some stuff, and then it's giving us a good output information. Okay, so the only thing you have to worry about is the block size. Block size is set to 4096. Okay, why is it set to 4096? Let's talk about it. Okay, so in the computer world, Um, what is byte means? Byte. One byte. Okay, this is the good image. Oh God, it started again. Okay, so what we have here is one byte is 1, 2, 3, 4, 5, 6, 7, 8. 8 bits starts with 1 bit, right? 8 bit, it makes it 1 byte. Okay? And the next level up is after 1 byte is 1 kilobyte. Okay, 1 kilobyte is, if you put together 1024 bytes, it makes it 1 kilobyte. And so on. 1024 kilobyte makes it megabyte. 1024 megabyte makes it 1 terabyte. Okay? So, how is the disk being used here? So, I'm explaining you what is this 1046 is. Okay, each block size. Okay, so what I'm gonna do now is get more space, indent it a little bit here. So the least size, if you are writing something on the disk, right, and if it's a 0 byte, you don't it's just creating a single file here. Okay, and it doesn't even have any information on it, but it still use the size of the space on the disk. Okay, so I'm gonna say disk space used by the file. Okay, and what we have here is block size is 4096. So this 4096 is the minimum size. 4096 is how much? 4096 is actually, you do the math here. So 1 KB, right? Let's see here if I do the math. I'm gonna use 1024
times 4, right?
times 4. Yes, very good. So the least size here is 4 kilobyte. 4 kilobyte is the minimum disk size. Okay, now we're gonna do some math here. If the size of the disk is so I'm gonna do this here. So I'm gonna say file size, and I'm gonna say disk space used. So what if the size of the file is 0 kilobytes, 0 KB? How much disk space you think is being used? So let's see here. I'm gonna do ls. I'm gonna do clear. I'm gonna do touch file 1. I do ls hyphen l. So I'm looking at the file here, and this file so what is the size of the file here? Is 0 here, right?
Yeah.
Yeah, this is 0. Okay, and then let's do stat file 1. Okay, but the IO block size is 4096. Let's do stat okay, let me clear this. ls hyphen l file 1. So in here it is showing you the minimum size is being used is 4096, and it's 0 here. If it's 0, it is using 4096 here. Okay, 4096. Okay, and if the size is 1 KB, the actual disk size is using still 4096. Okay, what if the size is 6 KB? How much you think is going to use now?
Still 4096?
No.
No.
because the maximum is could accommodate is 4, and after that is going to use 4096 times 2,
Okay.
so which is equal to um, 8 kilobyte. Okay, and if the size of the file is 8 kilobyte, it's still using 8 KB. Still using 8 KB. Okay, so 4096 4 KB equals 4096. Okay, so just here I'm gonna say 4 KB. 4 KB. So if it's using 6, 4 is already there, and then what is going to do for another 2 KB? It need to reserve another 4 KB for itself. Okay. Now you get the idea. What if it's using 12 KB? This file size is 12 KB. How much is going to use?
12 KB.
How much?
12 KB.
Yes, 12 KB. Because it's this size is moving in the increments of 4 KB
4.
each.
Yep.
If it's 13 KB, now it's going to use 16 KB. Okay? That's how it is. Generally, you don't touch this. You just leave this alone here. But if you're really, in today's time, the size, the disk space doesn't matter. It's almost unlimited disk space. Keep adding hard drives and hard drives and hard drives until they hit certain points. And I don't know, but we'll talk about that a little later more. But I think this got good information, right? Are you guys okay with this? Did I explain good enough, or you need a little bit more information?
I think you did pretty good. I got it at the end of it.
Okay. All right. So good. Here, I'm going to put this information here. So the thing we're looking at is this.
So, Mr. Zafar, can you do a stat hard dir
Yeah.
for the folder? And that's using 45 KB.
So the size of the file is 45 kg, but then it's using the disk space. So what you have to do is you have to do the math. How would the 45 would fit in? Okay, for minimum 45,
$48 times 12, 12K.
so it's 45, right?
144 KB.
No. Why are you doing 12? Okay, look at this here. It's using 4 KB
Yeah.
here. Right? So let's do 45 divided by 4. Okay, no, not 45. Let's look at 45 is what? 40 plus 5, right? 40 divided
Yeah.
by 4 is how much? Okay.
10.
So it's using 10 blocks. So we are worried about next 5 only. So next 5 would be how much the disk space is using? Plus 8.
Increments of 4, right?
Yeah. And the next 5 is using 8. So it is the disk space is 48.
Oh, okay. Okay.
No, yeah. If it were
Yes.
doing like
Uh-huh.
multiply and all that, then there's a lot of disk space being wasted. No.
Yeah, no. Yeah, I see what you're saying. Okay, thank you.
Yeah, that's a very good observation. Very good. So here it's an actual is using 48 KB and the file size is uh, 40 uh, 48, and then the disk size is I'm sorry, the file size is 45 and the disk size is, how much is the disk size? 48. So let's do, how do you use the disk space? The command is du and you type the hard drive in there. Uh, how do I do it? Du hyphen h. Let's see here. That's a directory, right? So how do I'm gonna do vi file 1. Sys 680 size du file 1. Disk usage is saying is a 4. File size is saying is 680. What is it using 680 bytes? Okay, I think I have it somewhere here. Let me find it. Permissions. Okay, so if it's in kilobytes, it would say K. So these are the information we are seeing is in bytes. It has not even reached this information in bytes. Okay, so sorry, the earlier information I told you is hold on. It's in bytes. Okay. So when this reaches more than 4096, then it will go to 4 KB. Okay, this information is showing is in bytes. Okay, I thought it was showing in kilobytes. But let's see, we're gonna do cat file 1, and what am I doing here? Can somebody tell me what am I doing here?
You're transferring whatever is in file 1 into file 2.
Yeah.
Or you could be changing the name.
No.
You're just transferring it.
Yeah. Okay, now the file 2 is 2027240. The file size still be the 4K. Okay, I'm gonna say du file 2. So the file size is still 4K because this number has not hit 4096 yet. So okay, now it has hit 8160, right? So 4096, how much is it? 4096 times 2. So now the file size should be how much? It is more than 8192. So the file size should be, it's going into the increments of 8. So the file size
Still
should be
less than 2 KB, right?
no. It
Is it
goes,
gonna be 8 KB?
yeah, 8 KB. Why? Because it's right on the borderline here. So it is under, how am I doing this? 4096 bytes times 2. I mean 4096 is 4 kilobyte, right? So 81960 bytes is how much? It's way under.
Yeah, 32 less than.
Yeah. So the size of the file 2 should be 8K. Yeah, 8 KB. There you go, 8 KB. Let's increase a little bit more here. One more. ls-l. Now is 8840, right? So way more than 8 kilobytes. So how much is gonna show the size of the file now?
12.
Very good. There you go. Now this should drive you home better. So this information, actually I'll keep this information here too. Anybody didn't understand? Talk to me right now, okay? If you stay quiet, it's not going to help you. Okay, so what happened here is this information is showing in, I'm going to get rid of this file 1 here. So I think if you do stat also, stat file 2, yeah, it's showing in bytes. Yeah, you gotta be use a ls hyphen ltrh. H stands for human readable. Now it is showing like 8.7 kilobytes. Okay, I think some of you didn't understand here. Who didn't understand? Please tell me now.
Oh, I got it, Mr. Zafar. Thank you.
Okay. All right. Anybody who didn't understand, put it in the chat, and then the few things you need to understand is the output. You have to understand what is the output here. Okay, the output here is in kilobytes. I'm sorry, these are in bytes. Okay, and then you have to understand it's using the multiples of 4 kilobytes to move up. The size is less, but the disk usage is different. So
So 1 kilobyte is 1024.
yes, I mean, to me bytes are meaningless here, but I don't know why it's showing up in bytes. Okay, so the minimum is 4096. Four kilobytes. The minimum space it's using is 4 kilobytes. Okay, even though you could play around and make it, I mean, if you have time, you could do that. But here's the thing here: if you're making a house and you want to, let's look at the example of shipping containers. Okay. Okay, right here, it's like each block is a container here. So if you ordered a product which holds like two and a half shipping containers, you still have to pay for 3. Did you get the idea? And if you have something you ordered is gonna, is gonna round up to next 4 kilobyte. That's what it's gonna do. Yeah, this is a good picture. Okay, so I'll put it down here. Okay, let's move forward here. Okay, and let's talk about the file system. Let's talk about the file system here, okay? Uh, okay. There are many file systems out there, but we are only worried about so much. Okay, so images. Uh, okay, what I'm gonna do is, let's see here. File system size comparison. I don't like this. Okay, I think I have better information here. So I'm gonna show you the differences between the file system. The file system you're gonna deal with are only four. Okay, and let's see here. 1, 2, 3, 4, 4. Okay. So I'm gonna type file system and the single size. Uh, Red Hat 6, Red Hat 7, and max disk size. Okay, there is a file system called ext2. ext2, okay, ext2. Red Hat 6, the size of the single file. Size of the single file. So a Red Hat ext2 file system, it could handle a size of a single file, could be 2 terabytes. Same with the Red Hat 7, it could handle 2 terabytes. And the maximum size of the one disk could be 32 terabytes. Okay, and the ext3, the single size of the file can be 2 terabytes and 2 terabytes. So there is nothing has improved here, I think. And the biggest size it could handle is 32. Then we have ext4, and the single size, if you have like a Word document, the size of the single document could be 16 terabytes. Okay, and this is also 16 terabytes, and the maximum disk size is going to be 1 EB byte. We're going to talk about this in a minute here. EB byte and terabyte, what is the difference? Okay, and the XFS file system, the single file size of the file could be 100 terabytes. When it comes to databases uses things like this here, and the Red Hat 7 could handle 500 terabyte and 16 exabyte. Okay, so let's get the differences here. So there is a new thing going around. One is used to be megabytes and the other is maybe bytes. Okay, the megabytes is 10 based, 10 to the power of, and the maybe bytes is 10 to the 2 to the power of. It's binary. So let's see here. Copied this time. Okay, here's the thing here. There is some difference going on here. Um, 10 kilobytes and okay, 1 kilobyte and 1 KB is let's do a math here. So I'm going to use 10 times 10 times 3, 10 times 10 times 10 times. So I do 10, 3 times is 1000, 1000, right? And I do 2 to the power of 2. So if I go like 2 to the power of 10, is coming out to 1024. And if you do 10 to the power of 3, is coming out to 1000. Oh God, it's messed up now. So how we are doing this time here is it's not into gigabytes anymore. We are using GB byte, KB byte, maybe byte. This is what is being used here. Okay, so we used to call it kilobytes, but it's being called as KB bytes, maybe bytes, mega. The one on the left is a standard, and the one on the right here is, if you say something as megabytes, right? Mega means 1000. But in actuality, it is happening 1024. Why is it happening 1024? Because here it is based out of 8. One byte is 8 bits. And then 1000 byte one byte is 8 bits. So if you do 1024 divided by 8, let's do that. This is 128. 128 So, did you get the point here that even though we have a concept of $1,000 $1,000 would be $1,000, right? But in computer world, it is not. Something related to 1,000 is 1024. 1 kilobyte is 1024. Okay, and then 1 megabyte is 10 times 10 times 1024. Let's do 10 times 1024. So 10,240. So why is it not doing? It's supposed to be 10,240, but it's doing 10 million. Oh, okay. It's supposed to be 1,000 divided by 10 times 1,000. So even if you're doing like a plain simple math here, it's not going to work as 1,000 here. 10 to the power of, you're not multiplying with 1,000 here. What is happening is you're multiplying 2 to the power of 2 times. You're not multiplying with the base 10, you're multiplying with the base 2. Let's see here. If you do 2 times, let me clear this. 2 times 4, you get 8, right? But you do 2 times 2 times 2 times 2. You do 4 times and you're going to get 16. So, but this is what I would say here. Don't sweat too much about it. Just keep it understanding here. Like just you would be dealing with only gigabytes and terabytes. That's it. You won't be dealing with anything else here. Okay. So that is a little bit confusing here, but you don't have to worry about too much about it. I just have to show you when it comes to this thing here. So let's get back here. I'm going to clear this lsblk. So let's look at the current status of our disk here. It's 4 GB. 8 GB, I'm sorry. So we have 16 GB and we have 4 GB being used here. Okay. So what does it look like? We have this disk here /dev/sdb, and how much is it? It's 16 GB. Okay, out of 16 GB, what we did was we made the partition, right? And how much is the size of the partition is? We made a partition /dev slash dev slash sdb1 is how much? 8 GB. So the partition 1 SDB1, which is a partition 1, is how much? 8 GB. Here we have another 8 GB free space. Okay, now the next concept is we want to use SDB1. How are we going to use it? So what I'm going to do is, it's called mounting. Mounting the disk. How do you mount disk? For you to be able to use the disk, first you have to create a folder. So I'm gonna do mkdir slash, I'm gonna call it Chicago. Okay, and what I'm gonna do is, I'm gonna say mount hyphen dev sdb1, and I'm gonna say Chicago. Okay, look close attention here. Over here it says is mount point is nothing here, right? Over here it will now, once I hit enter, it will say Chicago here on this side. So if I do lsblk, so the disk SDB1 is being used by the folder Chicago. Now if you put like 1000 files in here, all those files will be stored in this location, SDB1. Okay, welcome to Linux. This is what Linux is all about. Alright, who has questions? I take everybody has questions. Which part is not understandable? Anybody? You guys are still there, right?
Yes.
So what is your question? I know you got a question.
I'm good. I don't have any questions right now.
So you get the concept what I just did here?
Yes.
Okay, very good. So I'm gonna break up the command and explain you what the command means. So we have 1, 2, 3 parts to it. So this is the command, and this is the file system, and this is the mount point slash location. So in here, what is the command? Command is mount. And what is the file system? Dev slash sdb1. And then what is the location is being used in? Is being used in Chicago. Okay, yeah, if you get this, sometimes you get it all this in one try, and you may need to do a couple times to understand what is happening here. So now what I'm going to do is I'm going to clear this. This is how you mount it. Okay, if you want to unmount it, how are you going to unmount it? Unmount the disk. It's simple. All you have to type is umount / Chicago and hit enter. If you do lsblk, the Chicago is not being used with this. You don't see much information here after that. So now what I'm going to do is I'm going to mount it again. Okay, so the file system is there. And then there is another command. If you want to see the file system, you can type dff-h. If you type dff-h, it will give you the exact information. It's not going to give you information which is not being used here. This information is the hard drives which are being used now. Okay, so you type dff-h. This is the current stats. It's being used. So if something is not being used, it's not going to show is in the df command. Okay, I'm going to clear this. I type dff-h. So let me explain you. It gives you some information here that it's being used 1%, and with the disk usage, it is not going to give you the exact information here, information that the disk is not being used here. So you have like you have 8 GB, even though it's saying 7.8. Okay, why is it showing 7.8? Because some of the size or some of it is being used to store some information about the disk. So the available disk you have is 7.3. So 700 megabytes is being reserved for the system. Okay, it uses something called metadata. So it writes that metadata on itself. So that much information is not available. It's a good example is if you go buy an iPhone, 32 GB iPhone, they will say 32 GB, but when you bring it home and when you check the storage and all that, it won't be 32 GB, it would be much less. Why? Because it is taking some space for operating system, as well as to keep some information about the firmware, the metadata and all that. The computer system is a very complex system. Okay, what I just said is beyond the scope of this class, but you just have to understand, like in the computer world, you can't be master of everything. You may know a little bit about this and that, but you could be just master in one area, not everywhere. Okay, it's very complex, very widespread, and every day I hear something which has been out for 2 or 3 years or 4 years that I don't know about, and that's how those things are. Okay, so now what will happen if the system reboots? Okay, I'm going to restart the system and see what happens. To restart, you just type init6. It will restart. We're going to go over the commands, the restarting, the shutdown later. But right now just use init6 here. Okay, it's back up. I'm gonna log in. So if I type dffnh, the file system Chicago is not there anymore. Because why? Because what we have done was, it was temporary. So let me clear this. So the file system is okay. So what we need to do is, we need to make the file system permanent. Even if the system reboots, what you have to do is, you have to make the entry into the file. So what you got to do is, there is a configuration file in etc folder. I think I told you guys, etc folder keeps the configuration file, and the file name is fstab. So you go in there, and what you do is, you copy the very last line, and then what you do is, you paste it there, and you have to edit it. How do you
Question,
edit?
Mr. Zafar?
Yeah.
How do you copy and paste again?
Can somebody answer that? Okay, you have to use YY.
Why? Okay. Thank you.
Yeah. This, you have to practice the VI editor. I gave you everything in there, so go please practice that, and that way you will know. I mean, you should be spending at least 2 hours on the VI editor anyway. So you go here, you go to the course website, and the entire document what I'm putting together is there, and I split up the topics also. Here's the VI editor. Okay, you go in there and practice it few times. Yeah, it's gonna load here. So here you normally copy the line, and then here you use this for, you have to match it here. What do you have in here? dev/etc. Okay, and then dev/sdb1, and then what you're gonna do is, you're gonna give the place where it's being used, which is, you type /Chicago. Okay, and um, and here instead of swap, you have to give the name of the file system, ext4, and leave everything else. We're going to come back to what other means here. Okay, so this is what you have to make a entry into fstab. So the good practice is, copy the existing line and paste into new line and edit as needed. So I'm gonna explain you what this means. 1, 2, 3, 4, 5. Okay, so let's see here. Okay, so this is the file system. Uh, it's called file system. Also, it's called, yeah, just a file system here. And this is mount point and file system type. Okay, and then this is we're gonna come back here, not now, but in a month's time we come back here and explain you what default means. Okay, OS handles it, and then this is a priority. We'll come back to this here too. Okay, I'm gonna save and exit, and there's a command called mount -a. That means mount a means mount all the disks. So what does mount -a does is it reads the fs tab and it loads whatever the entry you have in there into the system. Before I run that, lsblk. So no, not lsblk. I'm gonna clear. I do dff and h, and you see the Chicago is not being used here. So I'm gonna type mount -a. So it reads the fstab file, and any missing from the fstab file, it will load it for you. If you type dff and h again, now you see the Chicago is loaded here. Okay, I think this is way more than enough for you guys for today. So I'm gonna reboot and see if it's gonna stick. So I'm going to make a note here. Okay, so hopefully this helps, and then I'm going to reboot. The file system should automatically load. So I'm going to reboot now. this time around, since we made a permanent entry into the file system, it will load it for you. So the reboot is complete. I'm gonna say root red hat, and then I'm gonna do dff and h, and you see the file system Chicago is loaded here. It kind of went up and down, but this is what it is. Okay, any questions? Okay, I'm gonna end here. If no questions, then we'll pick it up tomorrow or next week, I should say. And I'll see if I could have the assignment ready this week here. There was some problem going on with Comcast, so I wasn't able to. But we'll see how it goes, okay? Please use the chat if you have any questions. Take a picture, put it in the chat, and I want one of you guys to answer it. But if you can't answer it, I'll wait a little bit, then I'll answer it for you guys. And then if you guys are interested in group study, please talk to each other and do the group study. The more you do the group study, the better it gets. Okay, any questions? Alright, if no questions, I'm going to end here and we'll pick it up next week.
All right, thank you, Mr.
Thank you.
Alright,
Have a good one.
yeah, you too.